You send your profile picture, right? Yeah, but it's not showing. The Teams call.
Shall we start, Asha? Hashan, you are there?
Yes, I am.
Okay. Shall we start?
Okay.
Nilan? Shall we start? Okay, good morning all. So today we are going to look into the Azure Devops platform and to demo a sample CI/CD workflow that we have developed based on the Azure DevOps tools and platform. So if you look at this, just a start to the presentation that I think everybody knows about the DevOps concepts and what DevOps do. Basically, it's integration of developer and operation teams in order to improve collaboration and productivity. So it consists of the CI part and the CD part. So if you look at why Azure DevOps, why do you want to build CI/CD pipelines in the Azure DevOps instead of using the OpenAI tools and using your own runtimes in on-premise server environment? So one thing is the reliability. If you are using Azure DevOps, so it's a SaaS offering, so you can build your pipelines in the Azure hosted platform. So so it provides the reliability of your workloads, DevOps workloads. So you don't have to worry about the underlying infrastructure. So Azure provides two options. One is to Microsoft hosted runtimes, and the other is self-hosted runtime. So if you are using Microsoft hosted runtime, all the infrastructure used in the CI/CD pipelines are managed by the Azure. So in that case, you get the scalability, reliability, and high availability for your CI/CD workloads. And they are guaranteeing a uptime of 99.9. So if you want the reliability and scalability for your production runtimes, then it's better to go for a SaaS offering like Azure. And then the easily collaboration among multiple teams. So that provides Azure DevOps is basically provides all the GitOps facilities, and you can use all the Git operations within the Azure, and also it provides team collaboration. And then the maintenance cost, so its maintenance cost is low, so you don't need to purchase servers. I mean, high-end servers initially. So you can start. Azure offers some free services initially to start the CI/CD pipelines. So if you are just starting, you don't have to purchase servers upfront, and you can use their free services initially and then build on top of that and expand when you have heavy workloads. So that's also an advantage if you are going for Azure DevOps. And then also Azure provides up-to-date features like it provides all the tools that are required for CI/CD pipelines within their framework. So that's also an advantage, and also the built-in wikis are also there. So if you look at the environment, so you can create an Azure, you can create an account with Azure DevOps platform, and there are two options. So you can either start with your Azure repos, or you can start with your GitHub repo. So these are the tools currently available in the Azure DevOps platform. If you look at each feature, Azure Boards is basically it provides tracking your backlogs, and you can maintain your feature list, and similar to Jira Boards. So Azure provides its own Azure Boards tool for the planning and tracking of the work items. And then the Azure repos, it's similar to GitHub repos. The difference is that you can maintain your private repos in the Azure repos. So if you take GitHub, it's mostly for public repos, and but if you want to host your private repos, you have to pay for the GitHub. But in Azure, the private repos are free. Then the next feature is Azure Pipeline. So you can build your CI/CD pipelines using Azure Pipelines. And the test plans is just for the manual testing purposes. You can create your manual test plans and test cases within the Azure itself. And then you have the artifacts. You can store your artifacts generated from the CI/CD jobs. And so the purpose of these tools is to maintain your entire CI/CD journey within the entire DevOps journey within Azure, and you don't have to go to another environment to use any other tools. So you can build your DevOps workloads entirely within Azure using these tools. So if you look at the individual items, individual features that we discussed, so as I explained, the boards are basically to maintain your backlog, the work items, and track what items are already resolved, and what are the pending items.
So for like ongoing products, we have a can we like on the create a CSV file?
No, you can onboard your own product and create the CI/CD pipeline based on that. You have to build your Docker files. Those needs to be created first, and then you can upload your GitHub repo into Azure repo.
Will it be public like if we do like that?
Azure repos are private.
If you onboard product from our will it be publicly accessible or just
No, it's private. It's private repo and only access through the Azure subscription. So if you go to the next, these are the Azure repos. As I explained, these are private repos. Unlike the GitHub, so the GitHub also provide private and public repos. But if you want to host your private repos in GitHub, you have to pay for them. But here the Azure repos are free of charge, and you can you can import your GitHub repo into Azure using this import a repository option. So that is available in Azure. And then the pipelines, you can configure your CI/CD pipeline using this option. And if you look at the pipeline structure, so I think you already knows this. This is similar to Jenkins structure, and you have the trigger, and the trigger will initiate a pipeline. So the pipeline has stages, and each stage has jobs, and the jobs are having tasks. So this is similar to what you have in Jenkins structure. And then the test plans are basically to create your manual testing task, and you can keep track of the testing progresses and testing activities using the test plans. And then the artifacts, just to show the artifacts generated from your CI/CD jobs. And so if you, so this is basically a sample application I have deployed in the Azure. So this is from Docker samples available in the GitHub. So the application is a voting application. So this contains 3 microservices. One is for voting between 2 options, and the other is to the result microservices displays the result from the voting application, and then it has 2 databases using Postgres database for maintaining the data, and the Redis for caching the data, and this worker microservice will retrieve the data from the database into the Redis cache. So basically, so this is the structure of the application that deployed in the CI/CD pipeline. So if you look at the CI/CD pipeline that has been built in the Azure, so the CI part contains the Azure repo. The application is imported into Azure repo from the GitHub, and so the CI part has 3 stages. One is to build the Azure build the application. So it will create the image, Docker image, in the build stage, and then the push stage, it will push the image to the Azure container registry. So either you can push the images to Docker Hub or Azure Container Registry. In this case, I've used the ACR. Then the third stage is to integrate with the CD part. So it's basically a shell script that will update the Kubernetes manifest. So once the image is generated, the build tag will be updated in the Kubernetes manifest using this shell script. So that will trigger the CD part. So for the CD part, we have used Argo CD, that GitOps based CD platform. So the Argo CD will watch for any changes happening to the repository, and it will pull the image and deploy into AKS cluster. So the deployment, we are using the Azure Kubernetes cluster for deploying the microservices. Is it clear, or do we have any questions on this solution? Yeah. Ashan, is it okay?
Okay.
Okay. So if I go to the demo, so this is the Azure repository that we have hosted our application. So this is the voting, the application for the voting microservice. Then we have microservices for result and worker, and then other for the deployment. Deployment and service YAMLs are available in this folder. So these files will be used to deploy the application to a case cluster. So here I am to demo the automatic application deployment, the CI part and the CD part. So I will do a change to the basically this app dot the Python file. So before that, I will show the basically the CI pipeline that is already built into this. So the as I explained earlier, this has 3 stages: the build stage, the push stage, and the update stage. And so if you look at the voting service pipeline, so this so this has 3 stages: the build stage, the push stage, and the update stage. So configuring this pipeline is very easy. That you can without writing any code, you can create your pipeline using the template that Azure has provided. So as an example, if I go, if I create a new pipeline, so it first asks where is your code. So it can be in Bitbucket or GitHub or Azure repos. In my case, the code is hosted in Azure repos. So if I say, and you have to select the application, and then it provides ask for the template that you have to select for the pipeline. So for building my pipeline, I used this particular template, that's build and push an image to ACR. And so if you are using GitHub, if you are using any other platforms, you can use based on the templates that are available. Say Node.js, if you want to build a Node.js project, so you can use the template that is available here. Likewise, there are many templates that Azure is providing. So if you say show more, it will So the many templates that are even PHP templates are also there. So you don't need to write your code from the scratch if you are using these templates. So you can use, say, if you're using this particular Docker template. So you can use the Azure subscription that you're using, and then basically it will ask for the sign in. It will. I will go to the existing pipeline. So it will create a template similar to this. So this will indicate the trigger. What is the trigger that you are going to use? Here I have used the path-based trigger. So here you can give for which folder that you are going to monitor for any changes. So here I'm going to monitor the what folder, the what microservices folder for any repo updates to trigger the CI/CD pipeline. And here this particular tag indicates the runtime that you are going to use for running your CI/CD job. Here I've used a self-hosted runtime deployed in a virtual machine. There are two options as I explained earlier. So you can use a Azure hosted runtime. In that case, there's a cost incurred for that particular setting up the Azure hosted runtime. So in this case, I have used for the testing purposes, I use a self-hosted runtime deployed in a virtual machine. So here you can configure the runtimes using project settings. So here there's a project setting called agent pools. So in the agent pools, you can configure your Azure agent that will deploy a integration job in your particular virtual machine. So in the virtual machine, a second. So in the virtual machine, it's running a job, listening for any build pipelines that is executed in your DevOps environment. So here it's listening for any job. So once I do any modifications to a repo and start a DevOps pipeline, the agent will automatically run that particular job in the runtime.
Are you creating the instance as well?
Yeah. So first, if you are using your self-hosted runtime, you have to create your virtual machine first and link it through a agent pool and use it for the running your jobs. But if you are using Azure managed runtimes, it will automatically create the environment and it will run in the backend.
Okay. Then do we need to like define the script or is it run as service?
It will based on your, so it will scale based on your workload. You don't have to specify any VM sizes or anything, any specs or anything. It will based on if you based on the number of stages in the build and how heavy it is. It will create the own environment and it will run. That's an advantage of using a Microsoft hosted runtime.
can't we use that? What I'm asking is like if they are looking at buying a local server.
Yeah, even your laptop, you can use the laptop also. So it's a matter of creating an agent, and you have to link it with the DevOps pipeline. So if I go to the demo and I'll do a repo change in the application, I'll change basically the Python file to change this particular. Before that, I'll show the. CD part. So basically, so this is the Argo CD application that we have deployed in the AKS cluster. So this is deployed using a health chart. So the Argo CD, first you have to configure to integrate in the repository, and in the settings you can link a repository for continuous delivery path. So here I have linked basically with the repo that I have created for the application, the voting application, and you have to give the repository URL, and so that is then it is linked to the particular repository, and it will listen to any changes happening to this voting application. So that's how you link the Argo CD with the your CI/CD pipeline. So once that is linked, it will create an application. So this is the particular application that it will create in the Argo CD. And so if you look at the application, basically it has it provides the deployment structure starting from the application service, then the applications and the replica sets, and up to the pod level. So you can monitor the health of the each component deployed in the AKS cluster using the Argo CD monitoring tool. So if I show the application, so there is the application that is running in the AKS cluster, and it is a basically voting application. It provides two options. So you can use the application to vote for a certain vote for between two options in the application. So as I explained earlier, I will basically trigger the pipeline. The yeah, so I will change these two options. Say, first edit. I will change these options. say cats and dogs. And so once I commit this change to the repository, so it should start the CI/CD pipeline. So if you go to the pipeline and say the voting service, so it has started a new CD job, CI/CD job. So here you can see it's running the build stage now. So it will show all the progress of the CI job here. So now the build stage is completed. So that means the image is created, the build stage. Now it will start the push stage that will push the image to the SGAS. So now the push stage has started. And the push stage is completed. Now the shell script is running in the third stage to link the to update the manifest files with the image tag, the build tag generated from the build stage. Now the update is also completed. So if we go to the Argo CD, refresh. So now it has already synced and deployed that particular application to the AKS cluster. Now, if you look at this particular voting, so here what we have changed the voting application. So if you look at the voting application, so it will give. So these are basically the build tag that is it has tracked and deployed in the AKS cluster. So here a small thing that we have to do, because for the AKS cluster I have used I haven't assigned a public IP to the AKS cluster. So here basically we have to create a load balancer service to access the application from the front end. So if you look at the I will create a load balancer service from a cluster. So now it has the voting services has not port services has changed to the load balancer service, and it's basically waiting for the external IP. So now it has assigned the external IP for this service, and so check whether the application has been deployed correctly. Yeah. So now it has been changed to cats and dogs. So the change that we have done is properly propagated to the AKS cluster, running the CI/CD pipeline correctly. So this is how the CI/CD is implemented using Azure DevOps. So another thing that I wanted to show, so if you want to build, if you want to incorporate any other tools into your CI part, so the Azure has provided all other third-party tools like OWASP dependencies, Trivi, or any other thing, any other third-party integrations are already available in the DevOps Azure DevOps platform. So it's a matter of installing your third-party tool in the platform. Say if you want to use OS dependency to be integrated into your CI pipeline. So it's you just need to uh, add it into your DevOps platform. So if I say you want to add OS dependency, so I just need to mention the DevOps organization that I have already created. So if I say install, it will install the OS dependency in the my environment. So I can access those tools within the pipeline that I already has.
Richard, I have a question regarding that.
Yeah.
If we are keeping the sensitive information, so how can we keep that part in this process?
Sensitive information since Hasha?
That let's say when in source code we have some username and password. So how can we keep that one in the
So
secure?
Azure has provided for that. You can keep those in the there's an option called environments.
Okay.
So within the environments, you can create your own environment and you can securely maintain your secrets and other configuration information in that.
So is that mean that here we can use the Vault or something is the different solution?
Sorry.
Is that mean we can use Vault in this environment or
Yeah. Yeah.
it's
It's
a
a kind
different
of a
solution?
vault. It's a kind of a
Okay.
vault. So within the environments, you can create your secrets and also the other configurations securely. So even the Azure recommends maintaining your confidential information within the environment rather than using it directly in the pipelines. So in the
So how about the
pipelines,
configurations? That means in our applications we have a lot of configurations.
yeah.
So let's say if we are doing the continuous deployment part, there are something that some issues happening that new configuration that environment variable exists in new release. So how can we handle that one? That kind of thing.
Uh, so within the environments you can
Yes.
create your configuration and maintain it there. Basically, I haven't looked into that in depth, so I can create a sample environment and see how you configure it. So in the if we say the voting service, uh, normally so even the even things like this Docker registry service connection. So these things can be maintained in the environments, even your pool name. So that those things we can maintain in the environment rather than using in the pipeline. We'll try it out, Hashan, creating an environment and what are the parameters that you can maintain and how to create a vault also there. Do you have any other questions?
Is there any way that we can use this part that we are doing? Use Microsoft Postgres formula AKS class එක තමයි අපි deploy කරන්නේ. ඒක යා manage කරන්නේ නැහැ. ඒක අපි CD parts එක අපි manage කරන්නේ. Terraform එක අපි කරන්නේ ඒකෙන් දාලා කරන්නේ.
Infrastructure එක Terraform එකෙන් කරන එක ඕගොල්ලන් initially infrastructure එක හදලා තියන්න ඕනේ.
ඔව් infrastructure එක හදලා
දෙකෙන් දැන් මම AKS එක manually හදුවේ. AKS cluster එක manually හදලා මේ එක තමයි CI/CD compartment එක.
But අපේ product අපි වන්දු උත් කරගෙන යද්දී ඒක එතකොට අවශ්‍ය විදියට string එක හදාගන්න බෑ.
ඔව් ඒ කියන්නේ CI CD form.
Can එක ගන්න ඕනේ.
Can එක ඕන data files ටික ලියලා ඒ ටික අසයින් report එකට upload කරලා එතකොට අපි ඊට පස්සේ subsequent changes ටික එතකොට අපි report එකට commit කරාම අර CI part එක automatically initiate වෙනවා.
අපිට මේ docker නැතුව normally service
පුළුවන්. මෙතන තියෙනවා template තියෙනවා normal
Ansible එකේ තියාගෙන download කරලා ඒ වගේ කරන්න.
party report එකක් create කරන්න මේක Azure එකේම තියන්නත් ඕනේ නැහැ. GitHub හරි Bitbucket හරි ඕන එකට push කරන්න තියෙනවා. Current on report එක. අනිතනවා වෙන්නේ CI job එක හදනකොට mention කරන්න ඕනේ report එක මොකක්ද කියලා. Azure report එකද නැත්නම් Bitbucket හරි ඕන report එකක් link කරන විදිහට report එක මෙතන maintain කරන්න ඕනේ. ඒකත් එක්ක directly link කරන්න. Usually එයාට මේ free quota එකක් තියෙනවා. commercial යනකොට තමයි pricing. උගලන් යන්නේ දැන් මට මේක full environment එකට මම VM and AKS කොටම දැන් ඩොලර් 30 ඩොලර් 10ක් වගේ තමයි ගියේ. workload වලට ගියාම තමයි ඉතින් ගොඩක් charge විතර රන් වෙනවා නේද? ඒක අර in advantage එක අතර විශේෂ low cost එකක් නෑ මේ infrastructure හදාගන්න. ස්කේල් කරන්න පුළුවන් and they are admin මේක අනුව workload එක ගන්න. අපේ
ස්කේලබිලිටි එකේ ඩොලර් සෙට් වැඩි
pipeline front time එකේ scalability එක Azure කොහොමද manage කරන්නේ ඕන මේ workload එක and හරි normal application deployment එක හරි එයා ඔයාගේ pipeline එක කොච්චර heavy ද කියලා බලලා ඒකේ number of stages ගන්න analyze කරලා platform එක හදාගෙන parallel jobs උත් run කරනවා. يعني stages 10ක් වගේ 10 12ක් කියනවා කියලා හිතනවා. ඒක efficiently අර time එක minimize කරන්න ඕන නම් එයා parallel jobs ඉදින් run කරනවා.
අපිට parallel එකක් තව මේ instant එක දාගන්න කියලා හිම දෙන්න වෙයි.
Microsoft host කරනවා නම් ඒක mention කරන්න ඕනේ නැහැ. ඒ automatically scale කරනවා ඒක.
composer වගේ දැන් මොකද මේ server free time server එකේ මේ benchmark කරන්නේ බන් not benchmark උත් තියෙනවා. අපිට දැන් මේ composer API එක memory use කරනවා නම් 4GB වලට වැඩි තව instance එකක් දාන්න කියනවා එහෙම memory
කියන්නේ deployment part එක නේ. CD part එකේදී ඒක ඇවිල්ලා අර cluster configuration එකනේ. ඒ case එකේ cluster එක configure කරනවා නම් scalability එක define කරනවා CPU විතර percentage එකට වෙන්න තව ඒක CD part එක. Terraform level එකේදී cluster creation time එකේදී configuration ටික දෙන්නවා දීලා cluster එක create කරලා දෙනවා. එතකොට deploy කරාට පස්සේ ඒ scalability එක manage කරන්නේ cluster configuration. ඒ scalability එක එතකොට මේකට related නෑ. Terraform level එකේදී ඒ configurations ටික ඒක scalability එක manage කරන් pipeline එක run කරන් එතන scalability එක Asan gaya nih? Okay, thank you. People aware,
meeting.